Today, we're running a WhatsApp system design interview. 3 engineers, 1 ex-Meta interviewer 45 minutes to design a massively popular messaging app. I'm Sam, and this is going to be interesting.
I failed this exact question at Meta in 2023, spent 30 minutes on encryption algorithms and completely forgot about message delivery at scale. It was humiliating.
I made it through 4 rounds at Meta, but bombed on WhatsApp's phone number verification system. Turns out there's way more complexity than just send an SMS.
I worked on WhatsApp's infrastructure for 3 years before joining the interview team. I've seen every possible way to fail this question. Today, I'm the interviewer.
I'm here to learn how the sausage is made at WhatsApp scale. Seeing how they handle the fire hose of 100 billion messages a day is going to be fascinating.
Perfect, Dr. Sharma, you're our Meta interviewer. Riley and Jordan, you're the candidates. The clock starts now.
Design WhatsApp, you have 45 minutes, 2.7 billion users worldwide, go.
Okay, let me clarify requirements. Are we building just messaging or also voice calls, video calls, status updates?
Focus on core messaging, text, images, voice notes, group chats, 45 minutes, clock is ticking.
What about scale? How many messages per day? Concurrent users.
You tell me you have the user count, show me your reasoning.
2.7 billion users, not all active daily. Maybe 70% daily active, so 1.9 billion daily active users.
Average person sends maybe 50 messages per day, so 1.9 billion times 50. That's 95 billion messages daily.
Close, it's actually 100 plus billion, but your reasoning is sound. Now what does that mean for your architecture?
100 billion per day, that's roughly 1.2 million messages per second average, but peak hours could be 3 to 4x higher.
What's peak hour traffic look like geographically?
Oh shit, global time zones. India peak doesn't align with US peak, but regional spikes could be massive during local evening hours.
India alone generates 20 plus billion messages daily. Design your system architecture, start high level.
Microservices approach: user service, messaging service, media service, notification service, group management.
Stop your listing services without understanding data flow. What happens when I send hey to my friend in Mumbai?
Client encrypts message, sends to server, server stores it, finds recipient connection, delivers message, sends delivery receipt back.
What if my friend is offline? What if they have multiple devices? What if the message fails to deliver?
Store and forward, keep the message in the server until they come online, but wait, with end-to-end encryption, the server can't read it.
Exactly, how do you store encrypted messages that only the recipient can decrypt?
Server stores the encrypted blob without being able to read it. Uses the recipient's public key for encryption.
Wrong, that's not how WhatsApp encryption works. Anyone know the Signal protocol?
It uses key exchange, double ratchet. I'm not sure about the implementation details.
This is a core WhatsApp feature. Each client generates ephemeral keys. Server facilitates key exchange but never sees plain text. Moving on, how do you handle message ordering?
Timestamps, server timestamp when message arrives.
What if messages arrive out of order? Network delays, retries, multiple servers.
Vector clocks, logical timestamps, some kind of sequence numbering per conversation.
WhatsApp uses message IDs and client-side buffering. But you're missing something critical. What if I send a message and my phone dies immediately?
The message is lost unless client confirms receipt from server before marking as sent.
Good, that's why you see single check mark versus double check mark. Now design your database layer.
For 100 billion messages daily, that's insane, right? Load. NoSQL database, Cassandra, DynamoDB.
What's your partitioning strategy? How do you shard conversations across databases?
Hash the conversation ID, or hash the user IDs involved in the conversation.
What about group chats? 256 people in a group, which shard gets the message?
Oh crap, if you partition by user, then group messages need to be replicated across multiple shards. That's expensive.
Exactly. WhatsApp actually partitions by conversation ID, not user ID. All messages in a conversation live on the same shard.
But then hot conversations could overload specific shards. A massive group chat could bottleneck one server.
That's why group size is limited. Now let's talk about message delivery. How do you ensure messages reach all devices?
Push notifications, Apple push notification service for iOS, Firebase for Android.
What if push notifications fail? What if the user has disabled them? What if they're in airplane mode?
Store and forward mechanism. Keep trying to deliver until successful, but for how long?
WhatsApp stores messages for 30 days. After that, they're deleted. Why 30 days specifically?
Storage cost: if users don't check messages for a month, maybe they're not coming back.
Also privacy, less data stored means less attack surface. Now how do you handle media, images, videos, voice notes?
Object storage S3, but with end-to-end encryption, the media is encrypted before upload.
Yes, server stores encrypted blobs, but what about media compression? A 100 megabytes video kills mobile data plans.
Client-side compression before encryption, different quality levels for Wi-Fi versus cellular.
Good. WhatsApp heavily compresses media. A 10 megabytes photo becomes 200 kilobytes. Users hate it, but it works. What about voice notes?
Similar approach, compress audio, encrypt, upload to object storage.
But voice notes have streaming requirements. Users want to start playing before the entire file downloads. How do you handle that?
Segment the audio file, download in chunks, but with encryption that gets complicated.
Exactly, encryption and streaming don't play well together. WhatsApp downloads the entire voice note before playback starts. Trade-off.
Wait, that's why voice notes sometimes take forever to play. I thought my connection was bad.
Exactly, user experience versus security trade-off. Now let's talk about status indicators. How do you track if users are online?
Heartbeat mechanism. Clients ping the server every few seconds to indicate they're active.
What's the heartbeat interval? Too frequent wastes battery and bandwidth. Too infrequent gives stale presence data.
Maybe 30 seconds, but that seems like a lot of traffic for 2.7 billion users.
Let's calculate 2.7 billion users heartbeat every 30 seconds. How many requests per second?
2.7 billion divided by 30. That's 90 million requests per second just for heartbeats.
Holy shit, that's insane. No wonder presence features are so basic on WhatsApp.
Language, but yes, that's why WhatsApp shows last seen timestamps instead of real-time presence. Much cheaper.
Wait, so when I see online on WhatsApp, it's not actually real time.
Online appears only when you're actively using the app. As soon as you switch away, it disappears. No heartbeats needed.
That's brilliant. Piggyback on actual app usage instead of artificial heartbeats.
Now let's talk about group chats. How do you deliver a message to 256 people efficiently?
Fan out, send the message to all group members, but that's 256 separate delivery operations per message.
What if the group has a very active conversation? 100 messages per minute across 256 members.
That's 25,600 delivery operations per minute. The server would be overwhelmed just handling group message delivery.
So how do you optimize this? Think about the delivery pattern.
Batch deliveries: instead of sending immediately, collect messages and send them in batches every few seconds.
Interesting approach. What's the user experience impact?
Messages would feel delayed. Users expect instant delivery in group chats, especially during active conversations.
Exactly. WhatsApp prioritizes user experience. They do immediate fan out but optimize at the infrastructure level.
How do they optimize it then? Dedicated servers for group message delivery.
Think about the network layer. How do you efficiently deliver the same message to multiple recipients?
Multicast, but that doesn't work across the internet, unless you mean at the data center level.
Close. WhatsApp uses message deduplication and intelligent routing. But let's move on. How do you handle phone number verification?
Send SMS with verification code. User enters the code to confirm they own the phone number.
What if SMS doesn't work? Rural areas, international numbers, carrier issues.
Voice call fallback, automated call that reads out the verification code.
Good. What about countries where SMS costs are prohibitive or where carriers block verification messages?
Alternative verification methods, email backup, but WhatsApp doesn't use email.
WhatsApp has regional partnerships with carriers and alternative verification flows for edge cases. It's incredibly complex.
I had no idea phone number verification was so complicated. I thought it was just send SMS, enter code.
Most people do. That's why candidates fail on this question. Now, final challenge. How do you handle disasters? Data center outage, network partition, earthquake?
Multi-region deployment, replicate data across different geographic locations.
What about active conversations during a failover? Users in the middle of group chats.
They'd lose connection temporarily, but their messages would be queued and delivered once service restores.
What if the message was, "I'm having a heart attack, call 911"? How long is acceptable downtime for a communication platform?
Zero downtime. People rely on WhatsApp for emergencies. Lives could depend on message delivery.
Exactly. WhatsApp targets 99.99% uptime. That's 4 minutes of downtime per month. Every second matters.
That's insane pressure. How do you even achieve that with so many moving parts?
Redundancy at every level, multiple data centers, real-time replication, instant failover, extensive monitoring. It's incredibly expensive.
Time's up, Dr. Sharma. How did our candidates do?
Riley started well with scale calculations but got lost in encryption details. Jordan had good systems thinking but missed the human impact of design choices. Neither would get hired today.
The encryption stuff killed me again. I focused on the technical details and forgot about user experience.
That heart attack message example hit hard. I was thinking about system architecture, not about someone's life depending on message delivery.
Let's break down what just happened. This felt different from typical system design prep. This episode was brought to you by Unstruct AI, creating the most trusted AI news analysis platform, with a focus on the human cost. After all, progress without humanity isn't progress at all. We are back, Dr. Sharma. What separates WhatsApp system design from other messaging apps?
Scale and simplicity. WhatsApp handles more messages than all other messaging apps combined, but the user interface is dead simple. That constraint drives everything.
The 90 million heartbeat requests per second calculation blew my mind. I never thought about the infrastructure cost of presence indicators.
That's what I missed. I kept thinking about elegant technical solutions without considering the real-world constraints like battery life and bandwidth costs.
WhatsApp's engineering philosophy is boring is better. They avoid cutting-edge tech in favor of proven, scalable solutions that work for everyone.
The group chat fan-out problem was fascinating. 256 people times 100 messages per minute. I could feel the servers screaming.
What about the human elements? The emergency message scenario seemed to shift the entire conversation.
That's intentional. WhatsApp isn't just a tech product, it's critical infrastructure for billions of people. Your design choices affect real lives.
I never thought about someone using WhatsApp for medical emergencies. That 99.99% uptime requirement suddenly makes sense.
And the compression trade-offs. Users hate that their photos look terrible, but it keeps the service accessible in low-bandwidth areas.
The phone number verification complexity was eye-opening. I thought it was the simplest part of the system.
Phone number verification has more edge cases than the entire messaging infrastructure. Different countries, carriers, regulations, fraud prevention.
What's the biggest misconception candidates have about WhatsApp's architecture?
They think it's technically complex. WhatsApp's architecture is actually quite simple. The complexity is in handling edge cases and global scale.
I kept trying to show off with advanced algorithms and protocols, but WhatsApp succeeds because it's reliable and simple.
The trade-off discussions were brutal. Every choice has consequences at WhatsApp scale.
Exactly. At 100 billion messages per day, a 1% improvement in efficiency saves millions of dollars annually. Every optimization matters.
Let's get practical. For engineers preparing for Meta or similar companies, what should they focus on?
Stop memorizing system design patterns. Start thinking about constraints. What if this fails? How much does this cost? What's the user impact?
And practice the math. 2.7 billion users sounds abstract until you calculate 90 million heartbeat requests per second.
I need to understand the business context better. WhatsApp's revenue model, user demographics, global expansion challenges.
And the regulatory environment. Different countries have different rules about encryption, data storage, content moderation.
Most importantly, think about failure modes. What breaks when India has a festival and message volume spikes 10x? That's how we think at Meta.
Any red flags that immediately disqualify candidates?
Saying just use Kafka without understanding why, or microservices solve everything, or worst, WhatsApp is just a CRUD app. Instant rejection.
I almost said it's just storing and retrieving messages at the beginning. Good thing I caught myself.
The encryption complexity alone makes it way more than CRUD. Add global scale and it becomes a different beast entirely.
Also, candidates who focus only on happy path scenarios. What happens when things go wrong is more important than how does it work when everything is perfect.
What about the evolution of WhatsApp? How has the architecture changed since the Facebook acquisition?
Pre-acquisition, WhatsApp was 50 engineers serving 450 million users. Post-acquisition, it's hundreds of engineers serving billions. The engineering challenges are completely different.
That's incredible efficiency. 50 engineers for 450 million users. How is that even possible?
Erlang and obsessive focus on simplicity. They avoided feature creep and optimized relentlessly for core messaging. No stories, no games, no social features.
But now WhatsApp has business API, payments, status updates. That must have complicated the architecture significantly.
Exactly. Feature complexity versus architectural simplicity is an ongoing tension. Every new feature potentially impacts billions of users.
The payments feature alone must require completely different infrastructure. Financial transactions versus messaging have totally different requirements.
Separate infrastructure, separate compliance, separate security models. It's essentially a different product sharing the same client app.
Final question, what's the most important lesson from today's interview?
Scale changes everything. Solutions that work for 1 million users catastrophically fail at 1 billion users. You must think in orders of magnitude.
And user experience drives architecture. The heart attack message scenario completely changed how I think about system reliability.
Every technical decision has human consequences. Compression quality, delivery latency, uptime, people's lives depend on these choices.
I'll never look at last seen timestamps the same way. So much complexity hidden behind such simple features.
WhatsApp succeeds because it makes hard problems look easy. That's the mark of great engineering, invisible complexity serving obvious simplicity.
Dr. Sharma, Riley, Jordan, Alex, thank you for showing us what real system design interviews look like. This was enlightening and brutal.
Thanks for the reality check, Dr. Sharma. I have a lot of studying to do before my next meta interview.
This was more educational than any textbook. Seeing the real thought process behind WhatsApp's architecture was incredible.
Keep practicing, but focus on reasoning over memorization. The best engineers think through problems, they don't recite solutions.
And remember, every WhatsApp message you send now represents incredible engineering complexity. Appreciate the magic behind the simplicity.
Until next time, remember that the best technology is invisible. It just works, even when billions of lives depend on it.
And if you're interviewing at Meta, think about the human behind every technical requirement. That's what separates good engineers from great ones.
Time to go calculate heartbeat traffic for every app I use. This perspective shift is going to change everything.
And I need to understand the business context behind every technical decision. Architecture serves users, not the other way around.
This has been Unstruct AI, where we reveal the human complexity behind technological simplicity, and it's always more fascinating than you think.